Okay. So let's just go back to the beginning and just go through some general principles of hearing loops and why they're of benefit to hearing aid wearers. Um, this is traveling over old ground, but again, it's really just to reiterate what these systems are and how they're used by the end user. Induction loop systems are installed. There's millions of them installed worldwide in all different applications. Um, and we all the principle of it is that we have an audio source going into a loop driver, which produces a current, and this current flows through the hearing loop, and the current is effectively modulating with the audio signal, and this magnetic field that's created by the hearing loop is picked up by a device called a telecoil inside the hearing aid. Now, there's a number of different models, types of hearing aids that are available. These smaller models here, the in-canal and in-ear models, are of such a small size that it's you're competing for space, and invariably you will find that these models don't have any telecoil facility installed. Whereas these other three models have a behind the ear part to them. And there's more than sufficient space in here to accommodate a telecoil, which is this little device here. So it's a very small device. It's just a coil that picks up the magnetic field that is produced by the hearing loops that are installed. Okay, for public transport hearing loops systems should work in exactly the same way as any other type of hearing loop, whether it's a one-to-one hearing loop at a checkout or a large area loop system that's installed in an auditorium. Again, if you think of the hearing aid wearer's experience, they want to they expect a consistent level of performance from all these different loop systems that are installed in all different applications and all different scenarios. And public transport is no different from this. So you can see here that it still has to adhere to the same IEC standard that all the other loop systems have to. So we look at the frequencies response is the same. The uniformity has to be has to be good, and this the strength of the signal has to be within this 0 dB range. So we have at Contacta has developed a new driver called the VLD1. And we're going to go into a lot more detail about this later on in the presentation. But just to kind of give you an overview, it's a dual output and multiple input device. As you would expect, it's got advanced audio processing, digital processing, and it's tailored to providing a good, clear signal through through the loop. And also it's built for the the transport environment. So it's been tested to R10 tested, which is a requirement for vibration, dust proof, and also temperature variations as well. And it's it required to withstand these conditions and give consistent performance. So what are the components primarily that are required for a transport loop system?
Sorry,
Well, again,
JJ, would you be able to let Jim Scott into the webinar?
oh, yeah. Okay. Just give a second for these other two people to join. Okay, so the key components again are the same for any other loop system. You require the loop driver, which in this case is the VLD1, and the loop cable and the microphone. Now, the loop cable in this situation is a bit more complex than just a single round wire around the room or copper tape or an aerial fitted under a counter. The loop cable in this situation is can be quite complex, and we're going to go into that in a little bit more detail later on. Um, Similarly with the microphone, it's important that you select the correct microphone for the environment for a particular bus, depending on background noise and things like that. This is just a kind of an overview of the different drawings that you will expect to get from the bus manufacturers, and you can see how complex it can be to sort of like route the cable, for example, for the microphone, and the placement of the amplifier or the driver, and the placement of the microphone. So these are all things that we need to obtain from the customer, from the bus operator, to be able to install a satisfactory system. Okay, so let's look at a little bit more about the legislation. So, public service vehicles, certainly in the UK, there's a regulations mandate where hearing loop systems are a requirement now in new buses. And it's also actually been, implemented as retrofitting for existing buses as well. Accessible travel it's now become a legal obligation, but to be fair, it's an ethical obligation as well. If service providers are providing loop systems and other aspects of the public environment, then why shouldn't transport be part of that as well? Remember that it's 1 in 5 people, 1 in 5 users, have hearing loss. So if you think of a queue at a bus stop, if there's 20 people on that in that queue, 4 of them are going to could benefit from the system. You know. A large double-decker bus can hold 80 people. So you can, a significant number of that, 20% of these people are, could benefit from, the loop system. So it's not a trivial, service that we're providing. It's something that can be used by a great number of people. And of course, the IEC standard here is a globally accepted specification. So if we are able to, create a system that kind of adhere to this standard, then we know that, people with the hearing aids, with the telecoils, are going to be able to engage with the system and get good quality performance from it. And our Contacta transport hearing loop complies with the disability and safety regulations as well. So these satisfy these requirements. So going into a little bit more detail about the standard, again, we're familiar with this, with the key requirements being that our uniform field variation. It's one that plus or minus 3 dB variation. You're looking for a 0 dB level. And background noise limits. So, I mean, the background noise again should still be about, minus 32 or less. And again, we're going to go into this in a little bit more detail later on in the presentation, where, background noise is a significant problem in public transport on buses. And how do we manage this? So again, we're looking at this standard here has been basically created to, kind of satisfy the accessibility standards that have been set up both in the UK, in Europe, and the United States and worldwide. So these it all ties together. And again, it's to ensure that the end user, regardless of who they are and where they are, can access these type of systems and get good performance from them. And the importance of compliance effectively is that a poor system, if it performs poorly, then the end user is going to get a poor experience. And this is we don't want this. So what do we expect when we're actually on the bus? What sounds are we wanting to hear in the bus? So we've got onboard announcements, for example, when the next stop is, any safety information. We have driver communication where you step onto the bus, you want to say where you want to go. And you want to have that interaction with the driver, and the driver will confirm or whatever. And so, you have that live speech, one-to-one communication that has to be catered for with the loop system. And you've got general announcements and these private conversations that take place. So you've got these two types of uh, uses of the loop system being in place here. If we think of the sound sources, what are our sound sources primarily going to be on the bus? Well, it's going to be, a microphone to pick up the driver's voice. And we need to think about, what type of microphone we're going to use and where we're going to position it, because it needs to have a good, loud pickup from the driver, but also it shouldn't be that sensitive that it picks up a lot of background noise as well. So we have to monitor what the background noise is going to be like and what we have to do to mitigate that. We need to have integration with the existing bus audio systems. So again, we have to liaise with the bus manufacturers to find out just exactly what systems they have and how you're going to integrate with it. With some of them, it'll just be like an analog output. With others, it could be either a digital or an optical output, for example. So, these are things that we need to know about in order to be able to provide a satisfactory system. The careful placement of the loop aerials for optimum telecoil pickup. As you'll see, it's not a case of just being able to put, one big perimeter loop around the ceiling of the bus, and it'll work. We have to, there'll be areas that are targeted that we're able to, furnish with a loop signal, and then other areas that we can't. And this is where surveying becomes very important. And again, we're going to go into that in the next few slides. But part of the installation, we have to think of what are the practicalities of routing the feeder and audio cables, as well as accommodating the actual aerials themselves. Where are you going to locate the loop driver, and all these things that need to be thought about. So we're going to talk about, about the kind of what's required for the testing. How do we test for, loop installations on buses and vehicles in general? Most important thing is to, test under real operating conditions, which actually means doing a proper full road test as well. There's no point in having the vehicle sitting in the garage or on the forecourt, just idling, ticking over. That's not enough. You have to take the vehicle out on the road, have it going around corners, having it accelerating and decelerating. Because, for example, we've had buses where the power steering pumps, when they kick in, when the bus is steering, you get background noise being produced through, EMI, background noise being produced because of this. Now, if it's standing idling on a forecourt, you're not going to get that noise, so you're not going to pick that up. So it's all these things that you have to take into consideration, and you can only do that by doing a live road test. Your field strength meter is your friend here from the point of view of that this will give you all the data that you require. and so much of what background noise levels are. Um, and also when you're using a test loop, the test loops, the the signal that you get from that again is measured by your field strength meter. What's important about the test loops is that they must be installed in the final location where you want the actual loops to be installed to give you a really accurate representation of how a loop will perform. Um, there's no point in putting it, in a rough area or, hanging down from a roof panel or something like that. You want to have it sort of as close to where it's actually the final location is going to be, because even a difference of just ten, 5 centimeters or something like that difference can make a big impact on the performance of the loop. So in order to be able to do this, we really require significant cooperation from the customer and from the bus manufacturer, perhaps. So, we've already touched on this, but, access to the bus for surveys and installation. We need driver availability. And this isn't just a 5-minute job. This is something that could take, half a day to do. So, you have to be prepared to invest that time. And also, your customer needs to be prepared to have a bus, available and off the road for, a significant amount of time. In our experience, we probably say about, a day. Take the vehicle off the road for a day, and and have a driver available for, a significant amount of time. They don't need to be available for the full day, but certainly for the road test, a road test might take you an hour to do, for example. So, this has to be, the customer has to be made aware of this. Um, Before we get to the stage of actually doing the survey, we need as much information about the bus as possible. So the bus's specifications, um, things about, for example, their audio system, but not only that, the mechanics of the bus, how the bus is designed, what the access is like to the bus from the point of view of what panels can we take down to install loop systems or loop aerials. Because what you will find is that there's many parts of a bus that you can't get access to, and you can't install things in a discreet and kind of out of the way manner. Um, and then again, as part of the whole process, you're wanting to choose the right microphones and you know create the correct specification of loop aerials in order to satisfy the you know the the characteristics of that particular bus. So we're thinking of coverage and inclusion. So that's basically when you walk on the bus, where are we able to provide the loop you know uh, the loop signal? We've got two major challenges on buses. One of one of the biggest ones is the electromagnetic interference, the EMI, and there's a number of different sources of this, but generally speaking, it's from the engine and drivetrain. So the engine itself, normally the engine is located at the back of the bus. So you may find that when you move up to the back, when you're testing the background noise level with your field strength meter and your headphones, you're hearing this sort of like, funny whines and noises coming through from the alternator and the actual engine itself. But you also maybe find that there's, noise coming from the gearbox. If there's electronics associated with that. With hybrid buses and electric buses, you may find also that there's noise coming from the feeder cables for them that are feeding the electric motors. As I mentioned earlier, the power steering motors is uh, is another source where they're normally mounted at the front of the bus, and you've got the lead, or the electrical lead is maybe going from the engine, which is at the back, to the pumps at the front, and basically where that route is, that's a source of background noise. Um, the lighting in the bus saloons, again, can give you a level of background noise, like a high pitched whine. Um, and the control electronics, there's normally sort of like an area, um, normally kind of like around it, if it's a double decker, for example, around about where the staircase is, where all the control electronics are. And again, with your field strength meter, you're getting, picking up a lot of background noise from that area. So, as you can imagine, background noise is a big problem. And also, it can be localized. So you'll have certain areas of the bus which have insignificant levels, and you have other areas where it's just too loud and you're not able to install a loop system there because it's being overwhelmed by the background noise. Another thing that we have to think about is metal loss from the bus structure. I mean, at the end of the day, it's basically a metal box using a lot of aluminium, and aluminium is one of the worst metals for absorbing the signal from loops. Um, so we have this to contend with as well. Another thing that is, a thorn in the side is the restriction of where you can put the loop aerials. Just physically, you're not, there's a certain, especially if you're retrofitting into an existing bus, um, then you're restricted as to where you can install the loop aerials. And also, restricted access to how you route feeder cables and things like that. Another thing to consider is acoustic noise. It's not so much of an issue in the main sort of like saloon of the bus, because they're going to be listening to the announcement coming over the audio system. But the acoustic noise is important in the for the drivers one-to-one communication. And we may find that, for example, if it's a diesel powered bus, then the low pitched thrum from the bus is maybe getting picked up by the microphone and being heard through the loop. So you might be required to apply a high pass filter on the sound source going into the driver, to kind of like cut that low level frequency coming through and going into the loop. So you know these are the kind of like four sort of like major points again that we want to kind of go through. You need to identify potential sources of background noise and electromagnetic interference. Assess how the bus's metal structure will affect. It's not just a case of might, but it will affect the loop signal. And then from that, then determine the optimal loop placement for maximum coverage. And each bus model will have its own unique characteristics requiring a dedicated survey. So you may find, for example, you'll have a company that has a fleet of, say, 500 buses, and they will have different models, different manufacturers, different models of bus. So they may have, like, 10 units of one particular, model, and then, 100 units of another, etc., etc. You need to make sure that you conduct a detailed survey of each model of bus, because they will be different. They will have different characteristics. Some will be fantastic, have hardly any problems, and others will be an absolute nightmare. And you won't know this until you actually do a survey. So don't just assume that, one bus will be the same as the other. They're not. They're very different. And you have to make sure that you do a detailed survey for each model of bus. So here's an example of a bus where this is the lower level, the ground, the lower floor of a bus. You can see here that this is the back seat at the top, and then we have seats down the front here. This is a side elevation of the seats. So you can see here that we've got the seats at different levels. We've got a test loop being at the one level, and you can see here that the difference in height from like head height to where the loop is, or where the intended loop is going to be installed, you can see that we've got only 150 millimeters between the loop and where the telecoil is going to be in the hearing aid. And then down at the front, it drops right down to 800 millimeters. So there's a big difference in the listening height. So there's a difference in listening height here. Now, how can we account for this? How can we have one aerial being able to satisfy these different head heights? Well, in one answer, in one word, we can't. We can't do this using just a single turn loop. Here, if we just again look at this picture here, and if we look at the legend here, what's shown in red is that we've done a background noise test whilst the vehicle has been in an idle and also as a road test. This was actually a fully electric bus. So it wasn't a hybrid, it wasn't a diesel, it was a fully electric bus. And surprisingly, the background noise levels, both on the idle and on the road test, was very, very good. We were getting, minus 50 on average, or greater as a background noise. So from that point of view, it performed exceptionally well. In the green numbers, this is where we had the test loop, was just a single turn test loop with 2 amps flowing through it at 1 kilohertz. So the test signal that we're putting through the test loop was at 2 amps, and it was set at 1 kilohertz. And this is a single turn. It's a single turn loop, not a multi-turn, just a single turn loop. And in green, you can see where we've got the field strength meter in the tripod, and that's set at the head height for these different head heights here, where the head was going to be positioned. And these are the numbers that we were getting. Okay. So with this data, especially with the green numbers, we can then go back to the lab or go back to your workshop and start sort of like crunching some numbers and being able to create loops that will satisfy the requirements of this particular bus. So here is a picture of a photo of a bus, a multi-turn loop that was actually created when we were doing the test. So this was actually, Andrew Page, our one of our design team, went out to do a survey, a detailed survey of a bus, and actually on site actually created a multi-turn loop. But this is something that you can do back at your workshop or whatever. You create a multi-turn loop, to which will give you the required field strength for your particular situation. Now, with our loop aerial installations and loop design, so from the survey test data, we produce a bespoke multi-turn aerial. Now, if we go just back to this picture here, what you will find is that what you need to do here is you create a multi-turn aerial for this section, which would have more turns in it than the aerial in this section, because aerial is much this aerial is much closer to the heads. So, the listening height is far smaller. So you don't need as much magnetic field here. So, for example, maybe a single turn or two turns in the loop would be sufficient to provide us a significant um, a field strength that will work satisfactorily. In this section here, you're a bit further away, so you might need, 3 or 4 turns um, in this section to create the desired magnetic field. And then in the worst case scenario, where you've got the largest difference in loop and listening height, then you might require, 6 or 8 turns to um, generate enough field strength. Because remember that the current is going to be the same in all of these loops. It has to be because it's a single driver that's giving out a single amount, level of current. So the only way that you can change the magnetic field is to change the number of turns in each segment of your loop. That's how you can create a loop system that will satisfy all these different, head heights, the listening heights. So this is you go back to the client, and this is mapping out the areas where we were able to provide a, a loop um, signal. So we've got at the driver's cab here. So this is where you're going to have the one-to-one communication between the driver and the passenger. And then you have these areas here that you've identified from your survey as to where where they actually want the loop coverage, and B, where it can be provided because there isn't any background noise, or because the metal loss isn't too significant. And then if we look at this drawing here, this is the aerials that we're actually going to, the location of the aerials that is going to produce the magnetic fields required to satisfy these areas. So here's some examples of different installations of loops that we've put into buses. So this is a small loop. This would probably be located at the driver's position. And you can see here it's been mounted in the panel here, and it's a multi-turn loop. We can see that here that this one has been installed on a panel that actually just drops down. So this is a plastic panel probably, and you can see here how it's been attached to the panel. This is another example where the panel has actually been removed, and what we've done, it's difficult to see, but if you just follow the black um, conduit here, this is a loop here that's being affixed to the actual the ceiling of the bus, and then a panel will go on top of this to cover it up. So once you've actually installed, designed and then installed the your loop systems, we then have to bring it up to commission it to ensure that it meets the IEC standards. So again, we're using our field strength meters, and you're taking precise readings of the magnetic field in these designated areas that you've identified that requires coverage. One thing to, if every country has their own, standards, and it's just, obviously we have standards in the UK, but again, it's, for people that are in different parts of the world, you'll have different standards to adhere to. So again, it's just a case of ensuring that you comply with that. Okay, so let's go into more detail about the VLD1 driver that Contacta has developed. So as we mentioned earlier, it's uh, the whole purpose of it is to enhance the experience of the passengers, and enabling them to use their hearing devices with telecoil to tune into the audio announcements and also, that live one-to-one interaction with the drivers, uh, to make their experience much better. So what are the key features? So a list of a number of them listed here. So it's a dual output driver. So something similar to like our V Pros, it can act as a phased array driver. So it can, drive a phased array system if need be, um, or two independent perimeter loops. It's rated at 12 volts and 4 amps RMS. And it has multiple inputs. So it has microphone as well as line level, and also it has the digital input as well. So you've got a number of different options there that you should be able to, integrate with, any audio system that would be installed on buses. It's a headless unit in so much that there's no controls on the unit itself. There's some indicators on it, LED indicators, but apart from that, the way that you make adjustments to the driver is by connecting it to a laptop using a software graphic user interface. It has advanced, audio processing with, high frequency compensation, a background noise reduction, and automatic gain control. As I mentioned earlier, it's R10 compliant. So basically, it went through all these rigorous tests for to be vibration and fireproof. It will work in a range of temperatures. So if you think of in vehicles, especially in cold countries, it's having to work from minus below freezing temperatures to very very high temperatures. And it's designed to work in these conditions. And like all our other loop drivers, it's a Class D um, amplifiers, which is highly efficient. So you don't have heat problems to worry about, as well as the performance enhancements. Another thing that we have added to this, which I don't think is actually of something that is provided by any other manufacturer that I'm aware of, is pink noise masking. Now, what this is effectively is that, when we were doing the background noise tests, we were finding that we were getting a low level whine at a high frequency um, from certain components of the bus when it was, undergoing a road test. Now could be coming from like the lighting, or it could be coming from an actual, con uh, control part of the bus. So, reading as far as the sort of the standards were concerned, it was below minus 32. But when you were listening to this, sound through headphones, and also, somebody that was hearing it through their hearing aid using the telecoil, they were hearing this annoying, high-pitched kind of like, harsh rasping sound. And we thought, well, how are we able to overcome this? And one way we thought of doing this was to have pink noise actually being played through the loop system. So when you adjusted your hearing aid to the loop system, to the telecoil, to listened to the loop, you were hearing this pink noise. And the pink noise actually drowned out this kind of like high pitched, kind of harsh rasping sound. And it was basically it was a more comfortable experience for the for the end user. Um, and this was actually verified by hearing aid wearers who, when we had them on the buses or on the bus, sort of like doing a subjective test, they highlighted the fact that to begin with that they were hearing this noise from the bus. And then when we, adjust the system and applied this pink noise, and they heard, they were aware of the pink noise being there, but that was a far more comfortable sound to hear than the harsh buzzing that was coming from the bus. And so, therefore, it was enhancing the experience for the end user. And by listening to that, they were more likely to actually have their telecoil still switched on and hear the announcements when when the next stop was going to be, rather than switching it to the T position, hearing this harsh noise, and switching it off, and then therefore missing the announcements. So we found that this was a very good feature to have on the drivers, and I'm not sure that there's any other driver that has this feature included. Um, also has a 100-volt line input as well for those situations where that is the output from the audio system. Um, and as we've mentioned previously, you'll have a host of different input and output options. We've mentioned this before about our 10 compliance, um, and it meets these standards. And again, the reason for this, why does it need to be like this? It ensures reliability and safety in that challenging environment where there's a lot of vibration, huge temperature differences, and dust and things like that. It's a an unforgiving environment that it's having to perform in. The connectors that we're using is these Wago 769 series connectors here, which are incredibly robust. Um, the clamps for the wiring clamps are very secure, and also where it actually plugs into the sockets on here, it's very robust. They're not going to go anywhere. And this is the rear uh, the panel of the driver that you can see here. So this was the PC-based user interface. So you connect the driver via a USB lead, um, and this then allows you access to this window here. And all the settings are on this window. I don't think there's any other tabs. Basically, everything is controlled from this single window panel. And all the different, adjustments and such like are made from here. This PDF little window here, if you click on this when you're actually on the software, will actually open up a little user guide for you as well. So it'll take you through step by step how to set up the driver. Finally, again with all loop systems, service providers, you know, invest lots of time and money in installing these systems, but again, they're absolutely useless if the end user doesn't actually know that they exist. So we have to, let the passengers know that the system is installed and where it will work for them. So you need to ensure that the signage is placed in the areas where the system is going to work, and they will gravitate to these particular seats where the signs are. So it's important not to just have one at the front, a big one, a big sign saying, "Oh, loop system installed." That's not good enough. It actually has to be targeted. You have to tell the passengers what areas are being covered by the loop system. So, how Contacta, how can we help? Well, we've got a number of different projects that we're dealing, with different bus manufacturers. Again, because it's becoming legislation, new buses that are being provided and going on the road, um, it's a requirement that they have to have, listening enhancement systems installed. So we're able to, give assistance in how to conduct site surveys, giving, guidance on installation and, ongoing support thereafter. It's not just a case of that we say, right, well, install it and that's it. It's a case of the ongoing, you know, um, support that we can give. Um, it's you know, installing loop systems in transport and certainly in buses, it is complex. There's a lot more to it than, for example, doing even, installing a standard, large area loop, for example. Um, just as I would say it's actually even more involved and requires a lot more cooperation from others. Um, if you're doing a survey, for example, for a loop in an auditorium, effectively, you get given the keys to the EV cupboard and, into the auditorium, and you're just left to get on with it. Whereas with the transport, you require a driver, you require mechanics and people from the bus company that are able to, be on hand to remove panels and give you access to where you need to have access to, and also to take the vehicle out on the road. And again, it's not a 5-minute job. It's going to take you to, significant time to get the data that you require. Um, so it's something that can be done successfully. And if you think about it, you're not going to just be doing this just for one or two buses. You're doing this for fleets of buses, hundreds, even thousands of buses. So if you're able to secure, a contract with a bus company, you can see that there's, big dividends to be made. But also, from the point of view of being able to, certainly contact him with the driver and the investment and how we actually do the surveys and ensure that the loop systems that we install actually work well, means that it's good for the end user. And that's the end of the presentation. Um, I'd be really I'd be really interested to hear any questions that any of you would have regarding this. All your microphones are muted at the moment, but by all means, switch off
Thanks,
and
James. That was very interesting. Obviously, there's a lot to go through there and a lot to cover. So if you have any questions now or anything occurs to you after, please feel free to send us an email. You can email me or I go through. Oh, Richard Treadgold has messaged in the group chat, James.
okay, right, let's see what we've got. Yes, it is. It is available now. Um, um, if you call our sales department, Richard, they'll be able to give you details as to how you get a hold of it. Uh, again, it's a case of we would maybe be reluctant just to kind of like give you one from the point of view of that, it's more than just giving you the driver. You have to ensure that whatever you're installing it on, the loops that you're connecting it to actually work as well. So I would think of it more of it being we're giving you it as part of a package, as part of a whole, designed system, including the aerials, including the integration with the audio and such like. And the VLD1 driver is part of that. Um, so yeah, I would say the only cautionary sort of note I would say is, we were quite happy to give you a VLD1. Um, but yeah, I think think about the what you're connecting it to, and what are the aerials that you're connecting it to, how are they designed, and we would want to give you support in that as well. Um, Can it be installed outdoors? That's a good question. I think it would need some sort of containment. It's certainly not IP rated from the point of view that you can just stick it on a wall and, rain can hit it and it's going to be okay, because it does have perforations in it. So it's not completely watertight, for example. So mm, I would say yes and no to that question. Um, Obviously it's been sort of like, I would think that the circuit board will have been protected, so it's like dust proof and probably moisture proof inside. Um, but that's that's a good question. I would probably say no. I don't think it's rated to actually be used outside. I would need some sort of containment or protection. Um, Now that we're bound to have that information, Tommy. What's the minimum working temperature, and can it can it handle minus 30? Um, I would like to say that they're bound to have thought of that, but again, we can find that information out for you and get back to you, Tommy. Is that okay? Um, no problem. I mean, I think, yeah, I mean, I think the temperature range would have to be, pretty pretty wide. I know that we've tested our V15 drivers and such like have been tested up to like 60 degrees, for example, and have worked continuously. Um, but certainly the question of like the minus 30, it's I would think it would, but I would need to confirm that for you. Any other questions? Okay. Well, we'll stop the recording at this point.
Thanks, James. Just a reminder to everyone that every webinar